Okay, so this is section 10.5. We're going to talk about two things, recursion and iteration, or recursive rules or recursive formulas. So we'll start with that and kind of see how this worksheet set up. I'll do a couple examples, then you've got a couple practice problems. The practice problems will be your assignment. So I do a couple of examples again on something different, and then you'll do a couple practice problems, and then we get into iteration down on the bottom. But so in this first section, this is what a recursive rule looks like. You'll notice two things. They give you a term, and it specifies what term, and I think all of them are going to be the same one, a sub 1, meaning the first term. They tell you the first term is 5. Then they give you a formula to use to find the rest of the terms, to find the next term. So we've seen a sub n before. Like we've written a sub n. Usually that meant the last term. Really and technically it just means any term, the nth term. So I'm going to write here nth term. We will not use it as the last term in this case. The slightly different subscript, I guess, that we have is this n sub 1, or n plus 1, a sub n plus 1. If you think of it, we're not really adding 1 to the answer. That's not really what that means. The subscript means the position, like, of the term. So if this is the 5th term, a sub n plus 1 would be the 6th term. If a sub n was the 8th term, this would be the 9th term. It just means the next term. I'm going to go, instead of calling it the n plus 1 term, I'm just going to call it the next term. It's the next term after a sub n. So we're going to couple those two things, and we're going to be able to answer the question. It says find the first 5 terms. Well, the first term's already done for us. It tells us a sub 1 is 5. So I'm going to write that down. That was the first term. By the way, these are sequences. This is a sequence. So it's 5 comma. Now to find the next term, I want the next term. What do? You take, in this case, you take 2 times the term you already have. If you want the term after 5, you use 5. You plug in 5. 5 becomes the term. So you're going to take 2 times 5 is 10. So technically, what happened there, you don't have to write this down every time, but that was a sub 1. The first term was a sub 1. So we were looking for a sub 2. Okay, so now I want a sub 3. Well, if you want a sub 3, you're going to take 2 times a sub 2. That may be a confusing way to think about it, but it just means the previous term. If you want the third term, take the second term, which is 10, plug it in. 2 times 10 is 20. You want the fourth term? 2 times 20 is 40. First 5 terms, we got 1 more to go. 2 times 40 is 80. So that's all it is. It's saying take 2 times the term before it. So on number 2, the first term is negative 2. So you write that down. Now here, this one, be careful. Make sure you realize the 6 is not in subscript. So it's saying take negative 3 times the term, the nth term, negative 3 times the term, and then you add 6 after that. So if our first term is negative 2, and we want the next term, we want the term after negative 2, you plug negative 2 right in here for a sub n. So it's going to say negative 3 times negative 2. Well, negative 3 times negative 2, that's positive 6, and then you add 6 to that. 6 plus 6 is 12. So to find the next term now, you're going to plug in 12 this time. So you want the term after 12, so you plug in 12 here. Negative 3 times 12 is negative 36, plus 6 gives us negative 30. And there's our third term. Now if we want a fourth term, you take the negative 30. You plug it in place of the a sub n. So it'll say negative 3 times negative 30. That's positive 90. Plus 6 is 96. Now I'm going to use a calculator for the last one. It's getting kind of big. So we've got negative 3 times, and we're plugging in 96. And then we'll add 6 to that answer. We get negative 282. Okay, so now we've got 2 practice problems. So I would recommend stopping the video, pausing it, do these 2 problems, and then come back. Okay, I'm going to now move on to questions number 5 and 6. So 5 and 6, we're working backwards from what we did up above. We have the sequence. We've got 5 terms. We want to write it in a recursive rule. A recursive rule are like these equations we had up here. Notice there were 2 things in the recursive rules. You have your first term. It has to specify what your first term is, and then it tells you how to get your next term. So on this example number 5, we are going to indicate what our first term is. And the reason we do this is because we are going to then, the assumption is that you could give just the rule to anybody without the sequence, and they could figure out what the sequence is. So if they don't know it starts at 8, they're in trouble, because I don't care what you do the next term if you don't know where to start. So very important that you indicate what the first term is. Then we're going to give a rule for how to find the next term, the term after a sub n. So figure out what you do. What do you do to 8 to get 17? Looks like we maybe added 9. From 17 to 26, we added 9 again. Yeah, it looks like this is an arithmetic sequence. We're adding 9, adding 9, adding 9. So what we're doing is taking the term that we currently have, we'll call it a sub n, and you add 9. When you do that, you get the next term, a sub n plus 1. So a sub n plus 9 gives you the next term. Number 6, we know our first term is a sub 1. That's 8. Let's see, is it arithmetic again? Add 12, oh, and then I add 30, oh, no, so it's not arithmetic. I'm not adding the same number every time. Maybe it's geometric. I hope so, because those are the only 2 sequences we're really familiar with. But it's not terribly obvious what you multiply 8 by to get 20. So if we're checking to see if it's arithmetic, remember what you do. Define R. Take a term, like the second term, 20, and divide it by the term before it. Make a ratio. Try to simplify this. 20 divided by 8, they're both divisible by 4. So 5 over 2. So 5 halves is what we multiply to get from 8 to 20. Now we need to, before we assume that it's geometric and that we do that over and over again, we need to test another one and see. So let's test the next term. So from 20 to 50, take 50 over 20. Those are both divisible by 2, or I mean, sorry, by 10, giving you 5 over 2. Oh, look, they match. We could continue to test this over and over again, but it's going to work. I'll just tell you that. So we've identified what's happening from one term to the next. We're multiplying by 5 halves. So as soon as I know what's happening, I can write a rule for the next term, a sub n plus 1. What do? You take 5 halves times the a sub n. So a sub n plus 1 gives us the term after the a sub n. So it's like taking 8 times 5 halves gives you 20. It's like taking 20 times 5 halves gives you 50. So once again, there's practice problems on these. Just a word of advice as you're considering these. Start by figuring out what the sequence is doing. What are you doing from one term to the next? If it's arithmetic, if you're adding the same thing, super easy. You just add on your number. Or maybe it's subtracting. If you happen to have a geometric sequence, you just multiply your a sub n by whatever your r value is. So you're either adding your d if it's arithmetic, or you're multiplying by your r if it's geometric. Okay, so this would be a good time to pause the video so you can try numbers 7 and 8. I'm going to move on to the iteration. Iteration is very similar to what we just did, recursive rules. The wording is more confusing than anything else. Really, it's a composition of functions. But let's see what this says. It says find the first 3 iterates, we'll call them x sub 1, x sub 2, x sub 3, of, and then it gives us a function. F of x equals 3x minus 1 for an initial value of a sub 0 equals 5. So what we do is we plug numbers in over and over again into this function. It's telling us, oh, that should probably say x sub 0 instead of a sub 0, but I did that on all of these problems. Even on number 4 down there too. Sorry about that. So x sub 0, so we have like we'll call this the initial value. If the subscript is 0, it's not really our first term, it's just our initial. It's the first thing we're going to plug in. So if we want to find x sub 1, we take the initial value of the 5 and we simply plug it into the function. So we're going to plug 5 in to our f of x function, so in place of that 3. So it's going to say, then, if we plug in, if we're getting our first iterate, we're going to take the 3, plug in the 5, so 3 times 5 minus 1, what does that equal? That equals 14. So then, for the next iterate, or x sub 2, what we do is we take our newest value, the newest term, the 14, and we have to plug 14 in there. So we're plugging 14 in there, 3 times 14 minus 1, so that's 41. So x sub 1 was 14, x sub 2 is 41, and so now I need x sub 3. So you're going to take the previous value, the 41, and you're going to plug it in. 3 times 41 minus 1, that's 123, minus 1 is 122. So those are the first 3 iterates, 14, 41, 122. Basically, you could say they're the first 3 terms of that sequence. Okay, number 2. Find the first 3 iterates again. Gives us an initial value to plug in, -1. We plug it into our function. So if I want x sub 1, if I want my first term, plug in that initial value. So you're going to have to take -2 times -1 plus 5. So once again, in case I confused you, in case you're lost, we take the initial value, plug it into your function. Figure out what that is. That's your first term. That's x1. So -2 times -1 is 2, plus 5 is 7. So then, to find the next iterate, you take that value, the 7, and you plug that in. So -2 times 7 plus 5. So we get -14 plus 5 is -9. And then lastly, we want the third iterate, x sub 3. So we take that new value, -9, and we plug that in. So we had -2 times the -9, we plug it in there, and then plus 5. So -2 times -9 is 18. 18 plus 5 is 23. So they're my first 3 iterates. Okay, and so that's what you're going to do then for numbers 3 and 4. You get to practice the same thing. All right, good luck. This worksheet is the only assignment. So you'll finish this worksheet, you will turn it in class, and then you will have no homework over the weekend. I'll see you next